Thank you very much to everybody for still being here, and I'm the last one, so that's good news. Okay, I was asked to talk about AI and smart mobility. I'm in the same position as Nigel was, that I haven't done myself any of this work, but I will talk about some of the work that we have done. At the beginning, I was thinking about my university, but then I kind of did more than that and got some information from other people. I work in the Department of Transport Engineering and Logistics, and at the Instituto Sistemas Complejos de Ingeniería, Complex Engineering Systems, which is a multi-university system, and the BRT Plus Center of Excellence, where Nigel has been a member from MIT for many years. And what I'm going to talk today is based on the work of these colleagues, Professor Angelo Guevara, he's now the director of the Department of Civil Engineering at the Universidad of Chile. Hans Lebel, he's a member of my department, but also a member of the Department of Computing Science, and he has been in charge of trying to incorporate artificial intelligence and that kind of stuff in the work of my department. Professor Marcela Murizaga, who is kind of the pioneer in the use of big data and these kind of things in my country. She's now the academic and research director of the Faculty of Physical Science and Mathematics at the University of Chile. But I also managed to contact two people in the government, Viviana Muñoz, who is the big data coordinator for the Ministry of Transport and Telecommunications, and Alejandro Schmidt, who is the Intelligent Transport System Manager at the Direction of Public Transport, Metropolitan Public Transport of the Ministry of Transport too. So the work I'm going to talk here is based on the work of these people. First of all, I will mention very briefly the pioneering work. This was done basically first in 2012 about using smart car data, kind of big data, to estimate origin destination matrices. Marcela pioneered the work. She used the BIP smart card system of our integrated public transport system in Santiago, just to have an idea of how this system is. It has 6 metro lines with 140 kilometers of rail and 6,500 buses. They are all equipped with GPS. Now they are 80% of them are electric. We have about 11,000 stops and from bus and metro and also train, suburban train. And they can only be paid with using smart cards. And the system carries roughly 50% of the motorized trips in the city, 4.5 million trips per day. Santiago has about 6.5 million inhabitants. We now have, apart from roughly half of the trips also by car, we have now 8% of the trips done by bicycle. And so, Kai, you must be very happy with that, because we used to have only 4%, but it has increased alone to 8% really without us doing much, mainly because there has been a change in habits and in the perception of what transport should be in the future. I mean, now the car user is perceived as a bad guy who doesn't care about the environment. Before, it was perceived as the clever guy who would go everywhere happily, etc. So that is very nice, and it has been quite a nice change, in my opinion. Okay, the data that Marcela uses is the bus GPS, which is one record every 30 seconds. So we have about 80 to 100 million records per week, and the BIP transactions, which are 35 to 40 million records per week. And she also has information about the route paths, route assignments, the position of the bus stops, the position of the metro stations, and the position of the train stops as well. And the main challenges here are two, basically, that this card system is only activated at the start of the trip, not at the end. So it's not directly easy to find out when the trip finished. The only way to find out is the next trip that is started after. And this can be some very long time after, or very short time after. So it could be a transfer, etc. So that was a big challenge, and that was solved in 2012. And the other one big challenge is that in the bus system in Santiago, we have about 30% evasion rate. So it is actually very hard to know exactly which is the trip matrix when you know that mainly about 30% of the people are not paying for the bus component of the trip. This is not totally true, because when the trip involved a metro leg, metro has almost no evasion at all. So there is no evasion there, but there is an evasion part of the bus system. Okay. The results that she was able to provide were speed profiles, several types of indicators that are very useful for managing demand, and of course the public transport OED matrices. And the data, and there are two papers that I brought here. The first one is already cited by 354 people, so it has been very, very, very well read. But she also had the second one on fare evasion correction for this smart card-based origin destination matrices. And the data has been used for service design, system evaluation, infrastructure decisions, operational interventions, and of course, modeling. So that is my first example. The second one comes from these are public transport initiatives done mainly by this Office of Intelligent Transport Systems at the Dirección de Transporte Público Metropolitana. And they are implementing currently 3 projects. The first one is called digital payments. They were very concerned because in Santiago, these smart cards have now reached to something like 50 million plastic smart cards. They are not actually the latest version of smart cards, so they should be replaced. And this has been judged kind of unsustainable in terms of plastic and so on. So as I said, this is compounded by this problem of the evasion rate in the buses. So what they did was that in January this year, they implemented a QR code fare payment using your cell phone. And today, so only 7 months or something like that later, the system has already 1 million users, and 7% of the fares are collected digitally with a great savings in that sense. And also, this has allowed obtaining much improved socio-demographic data about the users, which in turn allows to design better services. The technology is quite versatile and allows to, and they are doing this now, adopting new transport and fare strategies like smart payments, fare capping, opening the way for a mobility as a service in Santiago. And I think that is quite good. The second one is called sensorization. They have now over 1,600 buses incorporating something called Mobileye Shield Plus Connect technology, which allows to detect blind spots around the buses using image processing, and allows giving warning to the bus drivers in real time. This will help to avoid accidents and particularly protect our active mode users, which are the most normally the most at risk from the buses, because our bus drivers, not like in England, they are not very nice. I mean, they drive really not caring about anybody else. So I mean, they have improved a little bit, but they have nothing to do with the British drivers, which I really admire. They don't feel that they are kind of being a pilot of a vehicle which is public duty. No, they are just having fun in the bus. So these sensors also allow to mapping mobility data in the city. Like, for example, they can provide you information about the size of the road, road signs, the width of the road of the line, the bus stops, where there are pedestrian crosses, the slope of the things, the time at intersections, the traffic flow, almost near accidents, and so on. So there are lots of information that you can be collecting all the time with this sensorization, and that is very useful for the government. Finally, the third project that they are implementing is a project on determining bus occupancy, because a large percentage of the bus fleet has installed inside security cameras, which are normally used for preventing robberies and things like that. But a pilot study is now testing the use of these images to estimate the occupancy by image processing and artificial intelligence. And this will also allow to infer the real use of the system, the real occupation, given that we have this high evasion rate. So that now we will know that although only so many fares have been paid, the buses are actually much more used than they appear or would appear to be. Okay, so that is from the part of this part of the government. The second, the Big Data Coordination Secretary, They started about 3 or 4 years ago a project which is called Digital Mobility Capture, which is a project funded by the Inter-American Development Bank. And they wanted to improve the collection of OD survey data using cell phone locations to estimate first the total trips generated per day, which is not an easy problem in urban areas because the antennas, you know, are kind of distorted by the buildings and so on and so forth. But then also a sample of users provides destination and mode choice data using a specially designed application for the cell phones. In Santiago, everybody has a cell phone, so it's very good. And if necessary, the latter information would be supplemented by computer-aided web interviews and by computer-aided telephone interviews. And that has been going on for about 2 years, and they have now a pilot project in where software was developed and has been conducted in an intermediate city to the south of Santiago, in Rancagua. That is working, and that I think will be an improvement over our typical data collection exercise that we carry about every 10 years. And finally, this office also has used the information from Waze and from 2 companies of cell phones, Movistar and Entel, to get information about movements by people during the day in the whole city, and they are being able to, for example, they used it to test how well was working the quarantine controls that have been proposed during the pandemic, but also they can determine when is the AM peak ends and finish and so on, all these kind of things which are useful for planning. Okay. Right, and now I will refer to more interesting kind of applications of AI and more new in the trying to estimate choice behavior. Hans Level, this colleague at my department with other colleagues, they have done 3 short projects to test the potential of artificial intelligence in improving our understanding of choice behavior, also user satisfaction, and also bus driver performance in a city which, as I mentioned, is rather notorious for their bad behavior. The first project is called Understanding Urban Perception Through Images, and it led to this paper in Landscape and Urban Planning, where they argue that the urban spaces are mainly perceived visually, and their perception influenced the use intensity and also the reasons for using the urban space. So quantifying the perceptions automatically should allow to identify likely candidates for intervention, and understanding these perceptions could lead to better interventions. So that was the idea behind the project. So what they did was they used a very interesting discrete choice model where they would use images that were presented to people, asking them to rate. This is a very large repository of images where people have answered the question, for example, which of these 2 images is more safe, which of these 2 images is more nice, which of these 2 images appear to be a more wealthy environment, and so on. There are lots of them, millions of them. But what they did was first using artificial intelligence techniques to parameterize the figures, and by color statistics, Canis algorithms, semantic segmentation, etc., things that I don't understand, they were able to disentangle the elements of the images and then estimate a model where each of these elements would receive a parameter which would be associated with whether they were agreeable or wealthy or safe or whatever, right? Using a discrete choice model with latent variables and so on. And the basic data are about over 100,000 images from 66 world cities that were taken from Google Street View in a thing called the MIT Place Pulse 2.0, that data set. It has 6 qualitative attributes, over 1.2 million preferences, and 81,000 users. And these are the kind of images that that are presented. And the answer that we have available in this data set is, for example, which of those two look safer, but there is no information about what are the components of the figure. So these guys they decompose the figures into having a car, having a tree, having a lawn, etc. Several images, right? Several, sorry, attributes. And then with that, they were able to estimate this kind of model with for the various qualification, being beautiful, being boring, being depressing, being lively, safe, and wealthy, right? And for example, here, if you look at the parameters for buildings, it means that the buildings tend to make spaces to be perceived as more animated, but less safe, more boring and depressing. Another one that they got was that the fences had an average positive effect in terms apparently of order and transparency. And for example, the top vegetation, the trees would be safer and more animated, less boring. And they have this information. And with this model, then they produce images for Santiago, and they applied the train model, if you want, to the images of Santiago, and also got qualifications whether they were wealthy or safe, etc. And then they did a lot of tests to check whether there was something like what we call sense checking, whether they made sense or not when they compare the results of the model with what you would know as a human of these different parts of Santiago. And it was actually quite interesting because it was great. I mean, the wealthy parts of Santiago were very well determined, and also the safer parts and so on. And the paper is, in that sense, quite interesting to look at. Now, they have some challenges yet, how to make the approach really useful for communities or decision makers, which would be the best intervention to generate a given type of effect in the use of the spaces, and is whether it's possible to incorporate other types of data. But I think that the application is quite interesting. The second one was analyzing public transport user satisfaction through Twitter. So they had this data mining, text mining techniques applied to Twitter, information about public transport gathered from millions again of tweets. And they had a very complex method of eliminating some that were not actually correct, etc. And they found no real brainer here. They found that 76% or 73% of the tweets were against. I mean, they were unhappy, etc. And they were able to also decode this. I didn't show the figure here, but they know why. I mean, the reasons for the discomfort of the people on the tweets. And also they found that they varied because they were able to separate them by location in the city. And they had this paper using Twitter for inferred user satisfaction with public transport, and which is actually, again, quite useful and shows a way of making our understanding of choice behavior a little bit better through these kind of techniques. And the final one was, I think, from this guy, these guys, is a very interesting one. They were trying to classify the behavior of drivers of public transport in terms of the way they drive. And what they did was they had this cell phone, which was able to have what they call inertial measurement, whether they were making lateral acceleration or longitudinal acceleration or vertical acceleration. The cell phone was located in the bus. I think you were talking about those possibilities, right? And they also had a hidden guy in the bus that was actually recording what was for him a funny movement by the driver, and then they correlated the two, and they found, and they did also with again with these techniques of I think it was called some. A tree of something or the other, and they found, for example, that these different leaves of the tree had different proportions in our data, and they refer to, for example, changing lane abruptly at high speed, sudden stop start at traffic light or congestion, or speed bump at high speed, or a slight irregularity. The two last were not a bad driver thing, but they were a thing of the road. And then they were able to, by route and length of route, they were able to eventually calculate a value, this B here, and the higher the value, the best it was the driver. For example, the driver of route 102 was much better than the driver of route 210B, etc. So they did this, and I think this was, again, quite an innovative and interesting application. Finally, the last one I want to talk about is by Angelo Guevara and colleagues at the University of Chile, which they are using machine learning techniques to help us understand better what people do when they choose. And they argue that among the latent variables that people normally consider when selecting an alternative are emotions. And they would like to measure emotions using physiological indicators, because there is a well-known knowledge base that says that there are a correlation between the emotions and the physiological states. So what they did was they wrote this paper, Psychophysiological Indicators for the Analysis of Transport Systems. They designed a special device. They call it the BioMonitor 3.0 wristband, which is a kind of little watch that you put onto the subjects, and that measures your heart rate variation, skin temperature, electrodermal activity, while you are traveling. In this particular case, I mean, the experiment was really nice because they had these people first kind of having a nap and being very comfortable, so that the older levels would be okay, because it's known that if they start being measured without this kind of thing, they may react a bit more kind of more than a normal person, because the normal person doesn't know that he's going to be measured. And also these people would do, this was an experiment that was very complete. It has microsimulation as well, but also the part I want to refer here, that they took a sample of 44 people that were prepared to participate in this experiment with the wristband, and they were made to do a kind of a use of different public transport services and walking, etc., in a kind of a long journey, and at the same time that they were being measured of their emotions, sorry, of their physiological data. They were also being asked using an app about how they felt, if they feel comfortable, happy, annoyed, angry, etc., at I don't know how many minutes intervals, using what they call this circumplex model, right? So they have the information of the two types, and they created with that, again, a system of latent variables with the two levels of the latent variables, and estimated a mixed logic model with a hybrid component. And here is the pass field experiment. So it was a sample of 44 students that was taken between November 1919 and January 2020. And they would start and walk, then take a electric bus, then another the same electric bus, then transfer to the underground, and then again walk a little bit and transfer to a normal bus, and then eventually transfer again to another electric bus, right? And during that path, they were being measured all the time, the bio data, but also they were getting this app request for saying whether they were happy or unhappy or whatever, right? And the results were that, for example, it was quite obvious that for them, the most unpleasant part of the journey was the transfer first, and also the part where they have to go in the normal bus rather than the electric bus. That was the bus. And then they reckon, after doing the study, that they were able to identify trip sections which trigger negative emotions and enrich discrete choice model with this kind of latent contrast. Okay, so they have this paper, that was published in Transportation Research Part C. And that is actually what I was wanting to tell you. Here are the references, in case anybody wants to have a look at them. And as Naya was saying, I'm also not there in any way, right? Okay, thank you.